Okay. Hello, good morning. In the last class, we are discussing about the structure and hybridization of halides. In the halides, hexafluoride we have to take SF6. In the hexafluoride, sulfur atom undergoes sp3 dehybridization. In the SF6 molecule, sulfur undergoes sp3 dehybridization, and the geometry and the shape of the molecule is taken as a octahedral geometry. In the octahedral geometry, one sulfur atom and four fluorine atoms are present in one sulfur, and four fluorine atoms are present in equatorial position. Therefore, maximum number of atoms present in equatorial position in SF6 is taken as F5. Two fluorine atoms, one is present in remaining two are present in axial position. On the SF4 molecule, here sp3 dehybridization, and the shape of the molecule is taken as a seesaw structure. In the sulfur containing one lone pair of electron. In the seesaw structure, this is the sulfur. Actually, sp3d means shape of the molecule is taken as a trigonal bipyramidal, but it contains one lone pair. Due to the presence of lone pair, the shape of the molecule is taken as a seesaw structure. Here in the seesaw structure, two bond pair, one lone pair is present in equatorial position. Two fluorine atoms and one lone pair is present in equatorial position. Remaining two fluorine atoms are present in axial position. Yeah, this is called seesaw structure. Here, if the lone pair is occupied on axial position, then what happened? Yeah, if the lone pair is occupied on axial position, this is the fluorine, 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 and this is the one of the lone pair occupied at axial position. So if the lone pair presented axial position, it can caused by three lone pair and bond pair repulsion. If the lone pair presented axial position, the lone pair bond pair, lone pair bond pair, lone pair bond pair repulsion is exist. These are the three fluorine atoms. This is the one lone pair. Therefore, lone pair bond pair, lone pair bond pair, lone pair bond pair. It is have three lone pair bond pair repulsions are exist. But in the seesaw structure, the lone pair is presented equatorial position. This is the lone pair, and this is the bond pair. This is the bond pair at axial position. Now it can cause two lone pair bond pair repulsions are exist. It can caused by two lone pair and bond pair repulsion. This lone pair, this bond pair separated by the large distance. There is no repulsion present in the lone pair and bond pair present at equatorial position. Therefore, it can cause two lone pair bond pair. It can cause three lone pair bond pair. Number of repulsions are increases. Stability of the molecule is decreases. Therefore, lone pair present at equatorial position is more stable. Therefore, the type of structure is known as a seesaw structure. In the SF4 molecule, sulfur undergoes sp3 hybridization, and the shape of the molecule is taken as a seesaw structure. Both SF4 and SCl4 both are act as a Lewis acids and Lewis bases. Both the compounds are act as a Lewis acid and Lewis bases. Here, this is the sulfur containing lone pair. Due to the presence of lone pair, these are act as a Lewis bases and also act as a Lewis acids. That means in the valence shell of these compounds having some vacant d orbitals are exist. Due to the presence of vacant d orbital, due to the presence of vacant d orbital, it can accept a pair of electron from other compound. It can accept a pair of electron from other compound. Therefore, these compounds are also act as a Lewis acid. Therefore, both SF4 and SCl4 is act as a Lewis acid and Lewis bases. Here, SCl4 and hydrolysis. SCl4 and hydrolysis to form a compound H2SO3. H2SO3 is called sulfurous acid. H2SO3 is known as a sulfurous acid one. The next topic is allotrophic forms. The next topic is allotrophic forms. Allotrophs means element having similar chemical properties but different physical forms are known as allotrophs. In these, oxygen, sulfur, selenium, tellurium do not form any allotrophs. Tellurium do not form any allotrophs. In the 1A group, in the 15th group element, nitrogen, phosphorus, oxygen, stevia, and bismuth. Bismuth do not form any allotrophs. Tellurium and polonium in the 16th group element, tellurium and polonium do not form any allotropes. In these, the first one is taken as oxygen. The oxygen is exist as a two types of allotropes. One is called dioxygen O2 and second one is called trioxygen O3. Here O2 molecule is a paramagnetic. O2 molecule is paramagnetic. O3 is diamagnetic. O3 molecule is a diamagnetic and also a angular structure. In the O2 molecule, it is a paramagnetic. That means it contains two unpaired electrons. According to molecular orbital theory, the two unpaired electrons are present on the O2 molecule, and the two unpaired electrons are present in pi star of 2px and pi star of 2py. Pi star of 2px and pi star of 2py. Here, O2 total number of electrons are 16. According to MOD theory, the last electrons are present in pi star of 2px and pi star of 2py1. Here, if Z is the internuclear axis, in this case, in the O2 molecule, bond order is taken as A2. Bond order is 2 means number of bonds present in between the two atoms are called bond order. Bond order can be calculated based on resonance and also calculated based on molecular orbital theory. According to molecular orbital theory, bond order is equal to 1 by 2 into N of B minus N of A. N of B means number of electrons present in bonding molecular orbital. N of A means number of electrons present in anti-bonding molecular orbital. Therefore, bond order is equal to 1 by 2 into N of B minus N of A. But in the here O3 molecule, O3 is the angular molecule and bond order is equal to, it is exist as the two regenerating structures. In the regenerating structures, number of bonds are taken as a 3. Therefore, when regenerating structures are given, bond order is equal to number of bonds by number of regenerating structure. Number of bonds are 3. Regenerating structures are 2. 3 by 2, that is equal to 1.5. In the O3 molecule, bond order is equal to 1.5. In the case 1, we have to take. Here, bond order increases. Bond length decreases. Therefore, bond length order of O2 and O3. Which one having more bond length is exist. The molecule which one having low bond order is more bond length. So bond length order of O2 and O3. O3 greater than O2. Bond length order of O3 and O2. O3 is greater than O2. Next, here this is the O2 molecule. Total number of electrons are present as a even number. Even number. Here generally the molecule containing odd number of electrons are paramagnetic. But O2 containing a even number of electrons, but it is even number of electrons are diamagnetic. But O2 molecule total number of electrons 8 plus 8 16, it is a paramagnetic due to two unpaired electrons present in pi star of 2px and pi star of 2py according to molecular orbital theory. So the molecules like B2 boron atomic number is 5, total number of electrons are 10, and O2 atomic number is 8, 8 plus 8 16, and S2 8 plus 8 16 plus 16 32. Here B2 O2 S2 are paramagnetic. B2 S2 O2 are paramagnetic. The paramagnetic nature according to molecular orbital theory, and the total number of electrons are present in even number. Total number of electrons are even number, but these molecules are paramagnetic. The paramagnetic nature can be explained based on molecular orbital theory. It can be explained based on molecular orbital theory only. These are the allotropes of oxygen. The next one is the sulfur. The sulfur forms a different type of allotropes. One is called alpha sulfur. Alpha sulfur is also known as rhombic sulfur. Rhombic sulfur is known as a more stable form. It is also more stable. It is also called yellow sulfur. It is also called yellow sulfur. And two is called beta sulfur. The beta sulfur is also known as monoclinic sulfur. Beta sulfur is monoclinic sulfur. And three is called gamma sulfur. And four is called chi sulfur or plastic sulfur. Chi sulfur and also called plastic sulfur. Chi sulfur or plastic sulfur. These are the four different allotropes of sulfur. One is called alpha sulfur, that is called rhombic. It is the most stable, and also alpha sulfur is also called yellow sulfur. Beta sulfur is called monoclinic, and gamma sulfur, chi sulfur is also called plastic sulfur. In this, first we have to discussing about the transition temperature. Discussion about transition temperature. Here, the transition temperature means the temperature at which the two forms are present at equilibrium position. Here, transition temperature means the temperature at which the two allotropic forms are. The two allotropic forms are present at equilibrium position. Therefore, the type of temperature is known as transition temperature. Here, alpha sulfur and beta sulfur are equilibrium to each other. Equilibrium to each other. The temperature is called transition temperature of sulfur. That can be taken as a 95.6 degrees centigrade, or the transition temperature of these compounds are taken as a 369 Kelvin. 369 Kelvin. At this temperature, in a mixture, both alpha and beta forms are exist. So both alpha and beta forms are exist means both alpha and beta sulfurs are present at equilibrium position. Here the transition temperature means the temperature at which the two forms are, two allotropic forms are equilibrium to each other. The temperature is called transition temperature. The transition temperature of alpha and beta sulfur. Alpha sulfur is called rhombic sulfur. Beta sulfur is called monoclinic sulfur. The temperature is taken as a 369 Kelvin. Therefore, transition temperature of alpha and beta sulfurs are taken as a 369. In this, the first we had discussing about alpha sulfur. Here, alpha sulfur is also called rhombic sulfur. Is also called yellow rhombic or yellow sulfur. Here, the melting point of rhombic sulfur. Here, the melting point of rhombic sulfur we have to take 385.8 Kelvin, and specific gravity, almost density. Density of compound by density of water is called specific gravity. The specific gravity of alpha sulfur is taken as a 2.06. 2.06. Here alpha sulfur insoluble in water. Alpha sulfur insoluble in water, but readily soluble in but readily readily soluble in carbon disulfide CS2, but partially soluble in organic solvent like benzene, carbon tetrachloride, and so on, but readily soluble in carbon disulfide, but insoluble in water. Here alpha sulfur insoluble in water to form colloidal sulfur is exist. The colloidal sulfur is also called chi sulfur and also called plastic sulfur. This is known as rhombic sulfur is called alpha sulfur volume. Here it is also containing S8 units are exist. The alpha sulfur, rhombic sulfur is also having S8 unit. Here S8 having Pucker ring configuration. S8 having Pucker ring configuration is exist. No doubt. The next allotrope of sulfur, that is beta sulfur. The next form is also called beta sulfur. Beta form of sulfur. Here, beta form of sulfur melting point is 392 Kelvin, and the specific gravity of beta sulfur is taken as 1.98, 1.98, and readily soluble in carbon disulfide, insoluble in water, but soluble in carbon disulfide. The beta sulfur is also containing SIT units are exist. The beta sulfur is also containing SIT unit. Here a beta sulfur is prepared from alpha sulfur. Beta sulfur prepared prepared from alpha sulfur. If the alpha sulfur heated to 1000 K high temperature, it changes into beta form. Both alpha and beta forms are chemical properties are same, but different in physical properties. Well, like melting point. Melting point of alpha sulfur is 385.8 Kelvin. Melting point of beta sulfur is 392 Kelvins are exist. Now, in these, in the different cases we have to discussing. In the case one, we have to take alpha, beta, and gamma. Alpha, beta, and gamma sulfur. Gamma is also a type of alpha beta form. Alpha, beta, gamma containing SIT units. These SIT unit is a Fucked ring kind of crown configuration. It is a crown or Fucked ring configuration. Crown or Fucked ring configuration. Crown or Fucked ring configuration. In the SIT unit, here this is known as a crown configuration. Sulfur atoms, sulfur, and sulfur atoms are there. In this case, SS, the bond angle is taken as 107. The bond length is present in between 2.06 angstroms to 2.12 angstroms. Here, number of lone pairs. The number of lone pairs, each sulfur having two lone pair of electrons. Each sulfur having two lone pair of electrons. Each sulfur having two lone pair of electrons. Now, in these, number of SS bonds is equal to number of SS bonds. 1, 2, 3, 4, 5, 6, 7, 8. Number of SS bonds are taken as a 8. Covalency of sulfur. Covalency of sulfur. Covalency means number of bonds, number of electrons participate in covalent bond formation is called covalency. Here each sulfur is participating in two covalent bonds. Therefore, covalency of sulfur is taken as A2. And oxidation state of sulfur. Here oxidation state of sulfur is considered as a 0. Here the covalent bond is present in between the same atoms. The covalent bonds are present in between same atoms. Therefore, the bond pair of electrons do not migrate to this sulfur atom and do not migrate to this sulfur atom. Therefore, the oxidation state of the sulfur atom is taken as a 0. Oxidation state of sulfur atom is taken as 0. Number of lone pairs. Number of lone pairs. Each sulfur contains two lone pairs. Total number of sulfur atoms are 8. 8 into C2. That is 16 lone pair of electrons are present in S-side configuration. The 16 lone pairs are present in S-side configuration only. In this SS bond angle, the bond angle is taken as a 107 degrees. Bond length in the S-side configuration, BL means bond length. Bond length is present in the range of 2.06 angstroms to 2.12 angstroms are exist. The bond length in the order of 2.06 angstroms to 2.12 angstroms are exist. In the case 2, boiling point of S8 is equal to 160 degrees centigrade. Boiling point of S8 units are 160 degrees centigrade. But S8 units melts above 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 120 degrees, that is 119 degrees. If the S8 unit and melted to above
Yeah, S8 units are changes into.
S8 units are melts above at 120 degrees centigrade. That means S8 units are stable up to 120 degrees centigrade. S8 units are stable up to 119 degrees centigrade. Above 119 degrees centigrade, S8 units are changes into S6, S4 and S2 units. The S6, S4, S2 units are known as a plastic sulfur. So that means the plastic sulfur containing mainly S6 units are exist. In addition to S4 and S2 units are there. That means if the sulfur is heated to, in the case 3, the sulfur is heated to above 120 degrees, the S8, that means sulfur heated to above 1 above 119 degrees centigrade, above 119 degrees centigrade, viscosity of that liquid is increases. Viscosity of liquid is increases. Here viscosity increases means up to 120 degrees centigrade only one unit is there, that is S8 unit only. Up to 120 degrees only one unit, that is S8 unit. After the crossing of 120 degrees centigrade, S8 units are broken into S6, S4, S2 units. So number of units are increases. Number of units, number of particles dissolved in a given solvent increases. Viscosity of that liquid is also increases. So S8 heated to above 119 degrees centigrade, viscosity of that liquid is increases one. Here, this is the plastic sulfur containing S6 units. Here, these S6 units are the S6 units are exist as a chair form. The S6 units are exist as a chair conformation. S8 are exist as a crown configuration or funnel ring structure. But S6 units are exist as a chair conformation. In the chair conformation, the chair form of S6 units are present in this direction. This is the one sulfur atom, sulfur, and sulfur atoms are there. Each sulfur is also contain two lone pair of electrons. The each sulfur containing two lone pair. Each sulfur is also containing two lone pair. Each sulfur atom is also containing lone pair. In this, number of SS bonds is equal to in this the number of SS bonds. 1, 2, 3, 4, 5, 6. Number of SS bond in S6 conformation is taken as a 6. Oxidation state of sulfur. Oxidation state of sulfur is also taken as a 0. Covalency of sulfur is also equal to 2. Covalency means number of covalent bond participate, number of electrons participate in. Covalent bond formation is called covalency. Here each sulfur is surrounded by two covalent bond. Therefore, covalency of sulfur is taken as a 2. Number of lone pairs in S6 conformation. Here each sulfur contains two lone pairs. Therefore, total number of lone pairs are 6 into 2. That is equal to 12 lone pairs are exist. 12 lone pairs are exist. Here S4 units are present in square planar and S2 unit we have to take. The S2 unit is a paramagnetic character like oxygen. S2 unit is a paramagnetic. According to MO2 theory, according to MO2 theory, the unpaired electrons are present in 5 star of 3p, 5 star of 3py1 and 5 star of 3px1. That according to molecular orbital theory, S2 is also paramagnetic. The paramagnetic nature of S2 molecule can be explained based on molecular orbital theory. It is also paramagnetic. It contains two unpaired electrons. One is present in 5 star of 3p1 and another one is present in 5 star of 3px. If Z is considered as internuclear axis, if Z is considered as internuclear axis, in the general case, the total number of electrons are odd number is a paramagnetic. Even number of electrons are diamagnetic. But the molecules like B2, boron, atomic number is 10. According to molecular orbital theory, it is also having unpaired electron. O2, total number of electrons are 16 is a even number. But according to molecular orbital theory, two unpaired electrons are exist. And S2 molecule, it is containing even number of electrons. It contains even number of electrons, but it is a paramagnetic. Remaining molecules contain even number is a diamagnetic, except these three. Boron, oxygen, sulfur, total number of electrons in each molecule is considered as even number, but it is paramagnetic. The paramagnetic nature can be explained based on molecular orbital theory only. Therefore, B2O2 S2R total number of electrons are even, but it is paramagnetic. The paramagnetic nature can be explained based on molecular orbital theory. Remaining molecule except these three, even number of electrons are there. Therefore, the type of molecule is considered as a diamagnetic. If the molecule containing even odd number of electrons, it is a paramagnetic. So except these three, no doubt. Bond angle 102 degrees. SS bond length is taken as a 2.05 angstroms. S and S bond length is 2.05 angstroms. SS bond angle is taken as a 102 degrees. No doubt. ఏమైంది? ఈ కిటికీ డోర్ తీసేయవలసింది, ఈ పక్కదే పూర్తిగానే లైట్లు ఆపేయవలసింది. రండి చెప్తాను. రండి చెప్తాను.
కులశేఖర్ నీ వీడియో కట్ చేయరా. కులశేఖర్ వీడియో కట్ చేయ. స్టూడెంట్స్ ఎవరు వీడియో పెట్టొద్దు. శ్రీనివాస్ సార్,
Oxohalides means compound containing both oxygen and halogens are known as oxohalides. Only sulfur and selenium to form oxohalides. Remaining elements do not form any oxohalides. These are two types. One is called thionyl chloride. Here thionyl chloride having the formula SOCl2. This is the one type. Thionyl chloride having the formula SOCl2. Here these are colorless fuming liquid. These are most of the cases colorless fuming liquid, and the boiling point of these compounds are taken as a 78 degrees centigrade. Here these are prepared by when PCl5 react with SO2. In the PCl5 dissociated into PCl3 plus Cl2. The two chlorine atoms are present at axial position. So to form a compound POCl3 plus SOCl2, POCl3 plus SOCl2. SOCl2 can be produced. Here these SOCl2 on hydrolysis. If the SOCl2 on hydrolysis, then the formed compounds are SO2 plus 2HCl is exist. SOCl2 on hydrolysis to form a compound SO2 plus HCl. Here these SOCl2 is also used in organic solvent, organic reagent like alcohol, ROH. When react with Thionyl chloride SOCl2, SOCl and Cl to form a compound. ROH is called alcohols. React with SOCl2 to form RCl plus SO2 plus HCl. SO2 plus HCl are produced. Now, in the structure of SOCl2, the structure of SOCl2. In the SOCl2, sulfur undergoes sp3 hybridization and it containing one lone pair of electron. Sulfur group number is 6. Oxygen is a divalent, chlorine is a monovalent. 6 plus 2, 8. 8 by 2 means 4. 4 means sulfur undergoes sp3 hybridization and it containing one lone pair. So sp3 and one lone pair, the shape of the molecule is taken as a pyramidal structure. Shape of the molecule is taken as a pyramidal. In the SOCl2, yes, double bond O, Cl and Cl and it containing one lone pair. In the SOCl2, oxidation state of sulfur is taken as a +4. Here in the S and Cl, Cl is more electronegative. Therefore, bond pair of electron is taken by Cl. Cl having negative and sulfur having positive. In the S and O, oxygen is more electronegative than sulfur. Therefore, two bond pairs are taken by oxygen having -2. In the S and Cl, Cl is more electronegative than sulfur. Therefore, this is the sulfur, Cl having -1 and sulfur having +1. In the SOCl2, oxidation state of sulfur, we have to take +4. +4 state is exist. And the shape of SOCl2 is taken as a pyramidal.
Next one is considered as a thionyl.
This is the thionyl chloride. A second type of oxyhalides are sulfuryl chloride. Sulfuryl chloride. The formula of sulfuryl chlorides are SO2Cl2. Thionyl chloride having the formula SOCl2 and sulfuryl chloride having the formula SO2Cl2. Here the boiling point of these compounds are taken as a 69 degrees and the boiling point of these compounds are taken as a 78 degrees centigrade or exist. It is obtained by direct reaction of and this can be prepared by when SO2 react with Cl2 to form a compound. SO2Cl2 is known as sulfuryl.
Here SO2Cl2.
SO2 directly react with chlorine to form a compound. SO2Cl2 is obtained. Here in this case, it is also used as a chlorinating agent. The SO2Cl2 do not undergo hydrolysis, but SOCl2 easily hydrolysis. SOCl2 react with water to form a compound SO2 plus HCl, but SO2Cl2 do not undergo hydrolysis. In the SO2Cl2, sulfur undergoes sp3 hybridization, and there is no lone pair of electrons. All are involved in bonding. Therefore, the shape of the molecule is taken as a distorted tetrahedral geometry. Distorted tetrahedral. Here the shape of the molecule is taken as a distorted tetrahedral. Generally, sp3 means tetrahedral geometry, but distorted tetrahedral means yes, double bond O, Cl and Cl. Why these molecules are exist as a distorted tetrahedral? In the distorted tetrahedral means these are the chlorines. This is oxygen. The chlorine occupy more space around the sulfur compared to oxygen due to the presence of big size of chlorine. So due to the presence of big size, there is a repulsion is exist. Due to the presence of repulsion, the shape of the molecule can be changes. Here, if the sulfur undergoes sp3 means geometry of the molecule is taken as a tetrahedral. But the presence of Cl, repulsion is exist, therefore shape of the molecule is taken as a distorted tetrahedral only. In the sulfuryl chloride, oxidation state of sulfur is taken as a +6. In the sulfuryl chloride, SO2Cl2 oxidation state of sulfur is taken. SO2Cl2 is exist. These are the example of oxohalides. Note down. Here, this one is also SOCl2 is the replacement of SOOH taken twice. SOCl2. SO2 Cl2 is also written in the form of SOOH taken twice when react with water. That means to form a compound of H2SO4. H2SO4 is produced.
Srinivas sir. Srinivas sir.
చెప్ప మర్ష
సార్ అక్కడ SU అనేవి ఫామ్ చేస్తాయి సార్. అక్కడ మీరు పైన రాశారు కదా SC అనేవి ఫామ్ చేస్తాయి ఆక్సో హాలైడ్స్.
సల్ఫర్ సెలీనియం టు ఫార్మ్ ఆక్సో హాలైడ్స్. Remaining element do not form oxohalide due to the presence of big size. Oxygen do not form oxohalides due to the absence of D sublevel. రమేష్ వస్తుందా అయింది ఎస్ఆర్కే బాగా వస్తుందా సెట్ అయింది కదండి నోట్ చేయండి అమ్మా వైఫై అందట్లేదు దానికి సరిపోద్దులండి అలాగ సార్ చూడండి ఫోన్ ఎందుకు నాకు కాల్ చేశాడు ఆ యాప్ చేసేసి ఆ మూల రూమ్ ఉంది కదా ఆ రూమ్ వేసి ఆన్ చేయాలి ఒకసారి ఈ లోపలేసి ఉంచు ఇది ఉంచు పైన ఈ పై రూమ్ ఉంది కదా ఆ ఏసీ ఆఫ్ చేసి సార్ అక్కడ క్లాస్ చెప్తున్నారు
సార్
ఏసీ ఆన్ చేసి
సార్
శ్రీనివాస్ సార్
శ్రీనివాస్ సార్
మాట్లాడు క్లాస్ ఆపిస్తాను
సూర్య చెప్పు
శ్రీనివాస్ సార్
ఆడేమో ఇది జోన్ 1 కదా సార్ మాకు సంబంధం ఉండదు సార్ అన్నాడు మొత్తం ఫామ్ అంతా కవర్లోనే ఉన్నాయి ఆడు హ్యాండ్ ఇచ్చాడు చెప్పాల్సింది అవును ఓకే ఓకే అవునులే ఓకే మెటీరియల్ వస్తాయనన్నా 4 సెట్లు ఇప్పుడు ఎస్ఎల్స్ అందరికి ముందు ఒక్కొక్క సెట్ ఇచ్చేయండి ఒక్కొక్క కాపీ ముందు ఇదే మామూలు ప్రెసిడెంట్ రన్ అవుతాను చెప్పండి అలా కాదు ఎస్ఎల్కి ముందు సెట్ ఇచ్చేస్తే ఇప్పుడు క్లాస్ చెప్పేటప్పుడు ఆ మెటీరియల్ ఓపెన్ చేసి చెప్పాలి ఎస్ఎల్ ముందు అది అవును ఇక్కడ అవును అంటే ఇక్కడ పంపించేది అక్కడే పెట్టుకోండి మనం ఏం చేయాలంటే ఇంక పంపించడమే ఇంకా డైరెక్ట్ గా పార్సలే ఇప్పుడు ఏంటంటే మన జిల్లా బోర్డర్కి వెళ్ళి అక్కడ అద్దె ఇచ్చేస్తే అక్కడ నుంచి వాళ్ళు పట్టిపోతారు హలో ఓకే మెటీరియల్ పంపించాలి పిల్లలకి డబ్బు కడితే పట్టుకెళ్ళిపోవాలి These are oxo halides. SOCl2 is called thionyl chloride. SO2Cl2 is called sulfuryl chloride. In the thionyl chloride, oxidation state of sulfur is +4. In the sulfuryl chloride, oxidation state of sulfur is equal to plus 6. In the SOCl2 and SO2Cl2 both undergoes sp3 hybridization. SOCl2 pyramidal geometry and SO2Cl2 is a distorted tetrahedral geometry exists. It is exist as a distorted tetrahedral. The next one is oxo acids. Oxo acids of sulfur. Oxohalides means compound containing oxygen and halogen is called oxohalides. Oxo acids means compound containing oxygen and hydrogen is called oxo acids. Oxo acids of sulfur means when SO2, these are called dioxides, dissolved in water to form H2SO3. H2SO3 is known as sulfurous acid. H2SO3 is known as sulfurous acid. When the trioxides dissolved in water, when the trioxide SO3 plus H2 trioxides dissolved in water to form a compound H2SO4. H2SO4 is known as sulfuric. H2SO4 is known as sulfuric acid. In this, and that is acidic nature of oxides SO2, SeO2 and TeO2, oxygen, sulfur, selenium and tellurium. Here sulfur is a strongly non-metal. SO2 is more acidic than SeO2. SeO2 is more acidic than TeO2. And SO3, SeO3, TeO3. Here SO3 is more acidic than SeO3. SeO3 is more acidic than TeO3. SO3 dissolved in water to form H2SO4. Here it can produced by H2SeO3. It can produced by H2TeO3, H2SO4, H2SeO4, H2TeO4. Acidic nature of these compounds are H2SO4 is more acidic than H2SeO4 is more acidic than H2TeO4, more acidic than TeO4. Now, the oxo acids of sulfur. Sulfur forms a different type of oxo acids. One is called sulfurous acid series. One is called sulfurous acid series. One is called sulfurous acid series, and two is called two is considered as a sulfuric acid series, and two is known as sulfuric acid series, and third is called thionic acid series, and third is called thionic acid series, and four is called peroxo acid series. Peroxo acid series. Here the sulfur forms four types of oxo acids. One is called sulfurous acid series, sulfuric acid series, thionic acid series, and peroxo acid series. In this case, the first we have to discussing about sulfurous acid series. Sulfurous acid series. In the sulfurous acid series, all these oxacids of sulfur, basicity is taken as A2. Basicity means it is having two replaceable hydrogens are there. So all oxacids of sulfur, basicity is considered as A2. That means it is having two ionizable hydrogens are exist. In this, first one is called sulfurous acid. Sulfurous acid. Molecular formula of this compound is taken as a H2SO3. Here oxidation state of sulfur is taken as a +4. The structure of the compound OH and double bond O. This is the sulfur containing one lone pair. Here hybridization of sulfur is equal to sp3. Sulfur group number is 6. 6 plus 2 8. 8 by 2 means 4. 4 minus 3 that is equal to 1. It is contained one lone pair is there. sp3 and one lone pair. Therefore, shape of the molecule is taken as a pyramidal geometry is exist. Now, in this case, number of sigma bonds is equal to, in a given molecule, number of sigma bonds is equal to atomicity minus 1. In a given molecule, number of sigma bonds is equal to atomicity minus 1. Atomicity of H2SO3 is equal to 2 plus 1 plus 3, that is equal to 7. 7 minus 1, that is here, 2 plus 1, 3, 3 plus 3, 6. 6 minus 1, that is equal to 5. 5 sigma bonds are exist. 5 sigma bonds can be represented as follows. Oxygen and nitrogen having single bonds are exist. 1, 2, 3, 4, 5, 5 sigma. Number of pi bonds. Only one pi bond is exist. Here in the H3SO3 sulfur having plus 4. The plus 4 state is present in first exit state. In the first exit state means electronic configuration 3s2, 3p3 and 3d1. So the electron present in d subshell is participating in pi bonding. Therefore, this pi bond is formed by overlapping of d pi p pi. So it contains only one pi bond is there. That one pi bond is called d pi p pi bond only. D pi p pi. And the salts are known as, and the salts are taken as a SO3 minus 2. And the salts are known as sulfides, ITE. Here, the salts of sulfurous acid is known as sulfides. Here, oxidation state of the sulfur is equal to plus 4. Only one sulfur atom. And oxidation state of that sulfur is considered as a plus 4 only. It is also exist as a tautomeric structure. This one is also exist as a tautomeric form. Tautomers means here the interchange of atoms in between two molecules is called tautomeric structure. Regenerative structures means atoms are present in same position. The bonds can be interchanged is called regenerative structure. Atoms can be interchanged is called tautomeric structure. H2SO3 and H2SO4 is also participate in tautomeric structure. The second is called thiosulfurous acid. Thiosulfurous acid. In the thiosulfurous acid means here in the H2SO3, 3 oxygens, one of the oxygen is replaced by one sulfur atom. Therefore, the formula of that compound is H2S2O3. In the thiosulfurous acid, the formula of that compound is taken as H2S2O3. In this, the structure of the compound S, OH and OH. Basicity of all these acids are taken as A2 and is also double bond S. Here, this is the sulfur behaves like oxygen. A thiosulfurous acid having the molecular formula H2S2O2. H2S2O2 is exist. Now, the structure of basicity of this acid is 2 and it is having 2 OH group. Another sulfur bonding with sulfur with a double bond. Due to the presence of double bond, this sulfur is behaves like a oxygen. This sulfur is behaves like oxygen. In the sulfur and oxygen, which one is more electronegative? Oxygen is more electronegative. Here, double bond is present in between the two sulfur atoms, and this sulfur is behaves like oxygen. Therefore, the two bond pairs are attracted by this sulfur atom. Therefore, this is the sulfur having -2, and this sulfur having +4 oxygen state is exist. The bond pair is taken by oxygen. This bond pair is also taken by oxygen. Overall oxygen state is taken as a +4. In the two sulfur atoms are there. One of the sulfur having, this is called a terminal sulfur. The terminal sulfur having -2 oxygen state. This is the central sulfur. Central sulfur having +4 oxygen state is exist. Therefore, average oxygen state of sulfur is, taken as a +1. In the thiosulfurous acid, two types of sulfur atoms are there. One of the sulfur having +4 oxygen state, another sulfur having -2 oxygen state is exist. And the salts are known as thiosulfides. And the salts are known as thiosulfides, ITE. The formula of thiosulfide is S2O2 minus 2. The formula of thiosulfides are S2O2 minus 2 only. So these are known as a thiosulfurous acid, no doubt.
శివా,
సార్ సార్ కెమిస్ట్రీ సార్.
చెప్పమ్మా.
సోడియం థయోసల్ఫేట్ oxygen state
Sodium
of sulfur atoms.
Two sulfur atoms are there. One of the sulfur having -2, another sulfur having +4. The average oxygen state is taken as a +1. Why the sulfur is exist as a negative oxygen state? In the general case, there is a multiple bonding is not possible in between one sulfur and another sulfur. Multiple bonding is not possible in between one sulfur and another sulfur. But in this case, there is a multiple bonding is exist in between one sulfur and another sulfur. Therefore, this is the sulfur behaves like oxygen. This is the sulfur behaves like oxygen. Here, oxygen and sulfur, which one is more electronegative? Oxygen. Therefore, the double bond, the bond pair of electron is taken by attracted by the sulfur. Therefore, this is the sulfur is exist as a -2. Two bond pairs are taken by the sulfur having -2, and the sulfur loses. Therefore, overall, the sulfur is exist as a +4 due to the presence of 4 bond pair of electrons. Cheppamma, Prasad.
So, sodium thiosulfate లో ఆక్సిజన్ స్టేట్స్ ఏమవుతుంది?
సేమ్ సోడియం థయోసల్ఫేట్ అంటే ఇక్కడ H ప్లేస్ లో Na తీసుకోవాలంటే. ఇదేమో థయోసల్ఫేట్ అమ్మా, ఇక్కడ H ప్లేస్ లో Na తీసుకుంటే దట్ ఈస్ కాల్డ్ Na2S2O2 is called sodium thiosulfite. Sodium thiosulfite.
SO2O3 O3.
అది S2O3 అది విల్ బి డిస్కస్ నెక్స్ట్ లో డిస్కస్ చేస్తాను దాని గురించి. అది కూడా సేమ్. ఇక్కడ ఏమవుతుందంటే S డబుల్ బాండ్ S అని వస్తుంది అనమాట. మళ్ళీ Na2S2O3 ఇక్కడ డబుల్ బాండ్ O వస్తుంది. అది తర్వాత డిస్కస్ చేస్తాం.
అక్కడ మళ్ళీ ఆక్సిజన్ ఉందని అస్యూమ్ చేసుకోవాలి సార్ అక్కడ.
సేమ్ డబుల్ బాండ్ ఉంది కాబట్టి ద సల్ఫర్ ఇస్ బిహేవ్స్ లైక్ ఆక్సిజన్ గా తీసుకోవాలి.
ఓకే థాంక్యూ.
చెప్తాను నెక్స్ట్ చెప్తాను. అది ఈక్ యాసిడ్ సిరీస్ లోకి వస్తుంది సల్ఫ్యూరిక్ యాసిడ్ అనేది. థయోసల్ఫ్యూరిక్ యాసిడ్ విల్ బి డిస్కస్ ఇన్ ఈక్ యాసిడ్ సిరీస్. Okay, in the acid series, another compound is called dithionous acid. Dithionous acid series. Dithionous acid. The dithionous acid is also called disulfurous acid. Another name of this acid is called disulfurous acid. In the disulfurous acid, having the formula H2S2O4. H2S2O4, it containing S and S single bonds are exist. Basicity of this acid is 2 means it is having 2 OH groups. Basicity of this acid is taken as a 2. It is having 2 OH groups are exist. And S double bond O and double bond O. Here, oxygen state of the sulfur is equal to +3. Oxygen state of the sulfur is also +3. According to this bond pair, the charge present on the sulfur is 0 due to this is the bond pair present in between the same atoms. Therefore, the bond pair do not migrate toward this sulfur and this sulfur. Therefore, the oxygen state of the sulfur is also +3 and this sulfur is also +3 volume. Next one is called pyrosulfurous acid. Pyrosulfurous acid. Pyrosulfurous acid having the formula H2S2O5. H2S2O5. Both having SS bonds are exist. Both the compound having SS bonds are exist. Pyrosulfurous acid H2S2O5. Here S and S. Basicity is 2 OH and OH. Double bond O and double bond O and double bond O. This is the structure of pyrosulfurous acid. Both containing S and S single bonds are exist. Remaining compound containing SOS bonds are exist. Here both the compound containing SS bonds are exist. H2S2O5. In the 2 sulfur, oxygen state of this sulfur is equal to +5. Oxygen state of this sulfur is taken as a +3. 2 sulfur atoms are there. One of the sulfur having +5 and another sulfur having +3 state. Average oxidation state of sulfur is taken as a +4. plus 5 plus 3 by 2, that is equal to plus 4. Here this one is a plus 5 oxidation state means this is the sulfur having plus 5. Here plus 5 means total number of bonds 1, 2, 3, 4, 5. The sixth bond is present in between the same atoms. Electronegativity of these two atoms are same. So this is the bond pair, do not give any charge present on the two sulfur atoms. 1, 2, 3, 4 bonding with S and O. O is more electronegative than sulfur. Therefore, this is the sulfur having plus 5. This is the sulfur having plus 3. The average oxidation state of sulfur is taken as a plus 4. Here in this compound, the SS bonds present in SS bonds present in S and S single bonds. S and S and single bonds are present in the compounds of H2S2O4 and H2S2O5. Another compound. Here thionic acid series we have to take H2S2O6. H2S2O6 belongs to thionic acid series only. So SS bonds are present in H2S2O4, H2S2O5 and H2S2O6. H2S2O6. Here H2S2O6 means S and S single bond, double bond O, double bond O, double bond O, double bond O, OH. This can be discussed in thionic acid series only, H2S2O6. The next one is taken as a sulfuric acid series. The next one is considered as a sulfuric acid series. The next we have to take sulfuric acid series. The sulfuric acid series. Sulfuric acid. One is taken as a sulfuric acid. One is known as a sulfuric acid. Sulfuric acid molecular formula H2SO4. Molecular formula of the compound is H2SO4. The structure of the compound, yes, double bond O, double bond O. Basicity of this acid is 2. It is having 2 ionizable hydrogen. Sulfur undergoes sp3 hybridization. The shape of the molecule is taken as a tetrahedral geometry. It is a H2SO3 sulfurous acid, H2SO3, sp3 and pyramidal. A sulfuric acid H2SO4, sp3 and tetrahedral. Here basicity of this acid, all oxy acids of sulfur having basicity is equal to 2. That means 2 ionizable hydrogens are there. Here number of sigma bonds is equal to atomicity minus 1, 7 minus 1, that is equal to 6 sigma bonds are there. Number of pi bonds is equal to, in the double bond, one of the bond is called sigma bond, another bond is called pi bond. It is having 2 pi bonds are there. The 2 pi bonds are formed by overlapping of d and p orbital. D and p orbital. Number of pi bonds are taken as a 2. Now, here oxidation state of the sulfur is taken as a plus 6. Here oxidation state of sulfur is taken as a plus 6. S and O. Which one is more electronegative? Oxygen. Therefore, it is having plus 6. Oxidation state is exist. Here, the another form of H2SO4 can be represented OH and OH. These in the modern concept, these double bonds are considered as a dative bonds. And in the formation of dative bond, each oxygen containing 3 lone pair of electrons. 3 lone pair of electrons are exist. Here, next, the salts are known as sulfates. The sulfates having the formula SO4 minus 2. In the sulfurous acid, the salts are known as sulfides ITE. The formula of the compound is SO3 minus 2. The salts of sulfuric acid is called sulfates. Sulfates are known as SO4 minus 2. Here H2SO4 is also called oil of vitriol. And the physical appearance of vitriol and H2SO4 is also known as king of chemicals. HNO3 is called aqua fortis. Aqua fortis means a strong affinity to water. HNO3 is called aqua fortis. It is strong affinity to water. H2SO4 is called Oil of petrol and also known as chemicals, also called king of chemicals. నోట్ చేయండి అమ్మా. Okay, the next type of acid is thiosulfuric acid. Thiosulfuric acid. In the sulfuric acid H2SO4, one of the sulfur is replaced by, one of the oxygen is replaced by sulfur atom, is known as thiosulfuric acid. The formula of the compound is H2S2O3. H2S2O3. In the H2S2O3, the structure is like that: S, OH, and OH, double bond S and double bond O. This is called the structure of thiosulfuric acid. In these, two sulfur atoms are there. This is the central sulfur atom. This is the terminal sulfur atom. This is the sulfur behaves like oxygen due to the presence of double bond in between one sulfur and another sulfur. Here, oxygen and sulfur, which one is more electronegative? Oxygen. Therefore, this is the sulfur having -2 oxidation state. This is the sulfur having +6. So, in the H2S2O3, two types of sulfur atoms are there. One of the sulfur having -2 oxidation state, another sulfur having +6 oxidation state. Therefore, the average oxidation state of sulfur is taken as a +6 -2 +4, +4/2, that is taken as a +2 only. And the salts are known as thiosulfates. The thiosulfates having the formula S2O3 -2. S2O3 -2. Example is sodium thiosulfate. Sodium thiosulfate. Sodium thiosulfate having the formula Na2S2O3. Sodium thiosulfate having the formula Na2S2O3. The structure of the compound SONA. Here, when react with sodium hydroxide, the two hydrogen can be ionizable. In the place of hydrogen, we have to take sodium, and this is also ONA, and double bond S and double bond O. Na plus O minus. Na plus O minus. This is the sulfur -2. This is the sulfur having +6 oxidation state. In the sodium thiosulfate, central sulfur atom having +6 oxidation state. The terminal sulfur having -2 oxidation state. The average oxidation state is taken as a +2 volt. The average oxidation state is taken as a +2. Next one is called disulfuric acid. The next is called disulfuric acid. The disulfuric acid commercial name is also called oleum and also called pyrosulfuric acid. The formula of the compound is H2S2O7. The formula of that compound is H2S2O7. Here in the H2S2O7 containing SOS bonds are exist. H2S2O7 containing SOS bonds. ఇక్కడ అడిగే ఆబ్జెక్టివ్ క్వశ్చన్ ఏంటంటే ఇచ్చిన కాంపౌండ్ లో which one having SS bonds are exist, which one having SOS bonds are exist అనే క్వశ్చన్ రైజ్ అవుతుంది. Oxy acids, 4 oxy acids ఇస్తాడు. Which compound having SS bonds are exist, which compounds having SOS bonds are exist. That can be identified based on the structure. H2S2O7 having SOS bond and the basicity of all the acids are taken as A2 and H2S2O7 and double bond O, double bond O. This is called pyrosulfuric acid or oleum. Here one of the sulfur having +5 oxidation state in the two sulfur. Here, this is the sulfur is also +6. This sulfur is also having +6 oxidation states are exist. In the pyrosulfuric acid or disulfuric acid volume, oxidation state of each sulfur is taken as a +6. In this case, number of SOS bonds is equal to 1. Number of SS bonds is equal to 0. Number of SS bonds is equal to 0. Number of SOS bonds are taken as a 1. Number of SS bonds are taken as a 0. Okay, no doubt. Ramu? Okay. నెట్ రావట్లేదు అక్కడ మొబైల్ డేటా మీద చెప్తున్నారా
అంటే వస్తుంది కానీ చిన్నది బ్లర్ రావటం అది మరి మన ముగ్గురం వాడేస్తున్నాం కాబట్టి సరిపోవట్లేదు ఏంటో
అది సెపరేటింగ్ బూస్టర్ ఒకటి ఉంది దానికి ఆ బూస్టర్ మీద కనెక్ట్ అవుతుందా అవట్లేదా కనెక్ట్ అవట్లేదా
లేదు నాకు అది ఛార్జింగ్
రాము క్లాస్ క్లోజ్ రాము